Hi everyone, welcome back to Learn Math with Jessie. Today we're going to cover how to simplify rational expressions with different denominators. So imagine the test you're given this addition between two rational expressions, so two values essentially with fractions. They have different denominators, right? So when we add fractions, we have to have a common denominator. So the way to approach this, right, is to factorize each of these terms. That way when we have the factored expression, we can see what they have in common and then go from there. So the first one, the first denominator is a difference of squares. I've covered this in a previous video. So it's essentially the square root of the first term minus the square root of the second term times square root of the first term plus square root of the second term. The second expression is a sum product, right? Also covered in another video. So we factor that accordingly. Now we rewrite everything in factored form, right? So we do it for the first expression and the second expression. And now we'll notice, right, that we have values in common. The x plus 2 is common to both. What's not common to both is the first x plus 2, the second x plus 2 in the second term, as well as the x minus 2 in the first term, right? So the way to approach this is our common denominator is going to have the x plus 2 that's common to both, the x minus 2 that's in the first, and the x plus 2 that's only in the second. So we therefore need to multiply the x by what it's missing, an x plus 2. And we need to multiply the 1 by what it's missing, which is an x minus 2. All right, now we can expand the numerator, right? So we can do the x plus x times 2 plus 1 times x plus 1 times negative 2, right? And then we keep the denominator still factored. Because now what we're going to want to do is we're going to want to factor the numerator, right? So first we group like terms, so we get x squared plus 3x minus 2. Again, we keep the denominator as is. And now we'll notice again at the top we have something that can be factored, right? So we can use the sum product method, again explained in previous videos, and we factor it out, and then we obtain x plus 1 times x plus 2, and we rewrite the denominator as is. The reason being is because now what we can do is we see that these x plus 2 terms cancel out, right? So now we have our fully simplified rational expression that we rewrite here. And we're done for this question. All right, let's look at a different example. Again, here the denominators are completely different. So for the first one, we can't factor it, right? There's nothing more we can do. But for the second one, again, we can use the sum product method to factor, and we obtain x minus 3 times x plus 8. All right, so again, what do we notice? We notice that they both have this x minus 3 in common. So that's going to appear in the common denominator, and we therefore don't need to multiply that lone x by another x minus 3 because it already has it. So essentially, all it's missing is this x plus 8. So we multiply it by the x. Now notice that I've put the x plus 1 in the second term in parentheses. Why? A lot of students make mistakes and don't distribute that negative, and they just do minus x plus 1. You really have to distribute that negative over the entire x plus 1 term. We therefore obtain x squared plus 8x minus 1. And then we rewrite the denominator as is. All right, now we group like terms and we obtain x squared plus 7x minus 1. So this expression is a little bit special because we actually can't really factor it using sum product. We don't obtain something nice. And if we have to get to the point where we need to factor it using the quadratic, we leave it as is in the numerator. This therefore means that this is the final expression. All right, now what if you're asked what are the restrictions on the domain, which would be nice actually, even if it's not asked to include as part of your solution. Well, we know that the denominator cannot be equal to 0. Therefore, each of these individual terms cannot be equal to 0. So x cannot be equal to 3 and x cannot be equal to negative 8. Thank you so much for tuning in to this video, and I'll see you in the next one.